In the quiet rhythm of time, as the wind brushed across the open plains and stars shimmered over silent deserts, humankind began its long and humble journey toward shelter. What started as a simple need to protect the body from rain, cold, and sun gradually transformed into one of the greatest stories ever told, the story of how we built the world around us. This audiobook is a gentle exploration of that story, from the earliest huts of ancient ancestors to the soaring towers of modern cities. We will follow the footsteps of builders, dreamers, and thinkers, those who shaped the earth beneath them, who learned to dig foundations, and who, over millennia, raised marvels in stone, wood, brick, and steel. Close your eyes, breathe slowly, and drift with us through time as we trace the foundations, both literal and symbolic, of human civilization. Long before cities, before writing, before even farming, there were shelters. In the Paleolithic age, tens of thousands of years ago, early humans found refuge in caves, rock overhangs, and natural hollows. These shelters were not built, but chosen, carved by nature itself. The walls of these caves, such as those in Lascaux and Altamira, bear the earliest marks of human presence, painted animals and mysterious signs. They were not just homes, but sacred spaces. As the climate shifted and humans moved beyond forests and cliffs, necessity led them to create their own structures. Using branches, leaves, animal hides, and later clay and stone, they built the first man-made shelters. Dome-like huts, anchored in the earth, crude but functional. They learned by doing. If a structure collapsed, they tried again. If rain seeped in, they changed the angle of the roof. Slowly, knowledge passed from parent to child, from tribe to tribe, and with every improvement, they moved closer to understanding something essential: the need to build on the earth, not just upon it. As humans began to settle in river valleys, grasslands, and coastal plains, their shelters became more permanent. Villages grew, and the structures within them needed to last longer. This shift led to one of the most significant discoveries in building history: the importance of foundations. Foundations began as simple trenches. Builders dug shallow pits, lined them with stones or packed earth, and set the walls of huts into these beds. This helped protect against moisture and made the structures more stable in wind and weather. In Mesopotamia, one of the first cradles of civilization, the Sumerians mastered mud brick architecture. They learned to raise their temples and homes on platforms to avoid flooding, compacting layers of clay and crushed reeds beneath them. Meanwhile, in ancient Egypt, the builders of tombs and temples developed deeper, stronger foundations, chiseling into bedrock and aligning their structures with mathematical precision. These weren't just functional, they were symbolic. A strong foundation meant strength, eternity, and connection to the divine. With each generation, trial and error deepened the wisdom of building. Builders learned that the ground beneath mattered as much as the walls above. Swampy land needed wide, flat foundations. Sandy soil demanded deep, anchored bases. And slowly, the science of building was born. As humans began to build more than mere shelters, as they dreamed of permanence, memory, and meaning, architecture rose toward the heavens. In Egypt, over 4,500 years ago, workers and architects shaped the Giza Plateau into something eternal. The Great Pyramid of Khufu, rising over 140 meters, was not simply a tomb. It was a testament to planning, labor, and geometry. Its foundations were carved into bedrock, flattened to astonishing accuracy. The Egyptians understood that even the grandest form needed a humble but stable base. Farther east, the Mesopotamians built ziggurats, tiered rectangular temples made of mud brick. In places like these structures stood as both religious centers and symbols of the city's strength. Their layered platforms were supported by thick, reinforced foundations that resisted the weight of their rising bulk. And in the Andes, long before the Incas, the builders of Caral and later Tiwanaku aligned their stone cities with stars and solstices, raising temples on leveled ground and stone-filled platforms. Each civilization, whether in Africa, Asia, or the Americas, discovered in their own way that no structure could endure without mastering the earth beneath. As societies expanded into empires, their architecture echoed power, order, and legacy. In ancient Persia, the Achaemenid Empire created Persepolis, a city of palaces, stairways, and halls supported by vast stone platforms. The builders first leveled a mountain slope, then created a terrace with a stone foundation that rose like a second earth. There, they placed pillars over 20 meters tall, each precisely aligned and anchored. In China, the imperial dynasties mastered rammed earth construction. Palaces, walls, and even entire city platforms were built by compacting layers of soil within wooden frames. The Great Wall itself, in many stretches, was founded upon deep, tamped earth layered with stone, a simple but effective technology that has endured centuries. From Minoan Crete to Angkor in Cambodia, from Babylon to Mohenjo-Daro, ancient cities pulsed with innovation. Drainage systems were dug, stone-paved roads were laid. Foundations were not only for strength, they were part of an emerging understanding of infrastructure. Trial and error remained the master teacher. Buildings that fell taught lessons. Those that stood inspired awe. With the rise of organized religion came sacred spaces built not only to last, but to elevate. In Europe, as Christianity spread, great cathedrals soared skyward. The Gothic cathedrals of France and Germany were marvels of engineering, with flying buttresses, ribbed vaults, and pointed arches. But none of this would have been possible without meticulously planned foundations. Builders first dug deep trenches and filled them with crushed stone, lime mortar, and in some cases, massive timber supports to distribute weight. In waterlogged areas, such as Venice, entire churches like St. Mark's Basilica were built on thousands of wooden piles driven into the mud, a forest beneath the floor. Similarly, in India, temple architecture reached astounding complexity. At Khajuraho and Madurai, temples rose on plinths with sculpted steps and stone base layers intricately joined with interlocking techniques. In Islamic architecture, foundations supported domes and minarets across Persia, the Middle East, and North Africa. The builders of the Alhambra in Spain and the Shah Mosque in Isfahan combined beauty with structural intelligence, anchoring massive walls in geometric grids and layered footings. Religion brought ambition, and ambition demanded innovation in how buildings began from the ground. With the Renaissance, architects began to think like scientists and artists in equal measure. In Italy, inspired by Roman ruins and new ideas in mathematics, builders like Filippo Brunelleschi and Leon Battista Alberti redefined space and proportion. Brunelleschi's dome over the Florence Cathedral is still a marvel, not only for its soaring height, but for its double shell design, which sat atop carefully reinforced stone foundations. During this era, drawings became plans, geometry became blueprints. Builders used grids, compasses, and formulas to design foundations that could bear domes, facades, and courtyards. The palaces of the Medici, the churches of Rome, and the villas of Venice all began with rigorous site preparation. Engineers studied soil. They tested weight loads. They documented what worked. Knowledge now traveled through books, apprenticeships, and universities. The mystery of building, once hidden in the trial and error of villages, became a science in the hands of scholars. While cities and temples rose, so too did castles. In medieval Europe, security was essential. Castles were built on hills, cliffs, and rivers, and their foundations had to adapt. Some, like the Crac des Chevaliers in Syria, were anchored into rock. Others, like the Tower of London, stood on marshy ground, supported by vast stonework layered over wood and earth. Moats were dug. Walls were thickened. Builders learned to redirect water, to prevent siege damage, and to fortify corners and gates. In Japan, feudal castles like Himeji were raised on massive stone bases designed to resist both earthquakes and enemy assault. The layered foundation stones followed natural curves and were locked in without mortar, allowing subtle movement during tremors. In each culture, builders learned that security came not only from high walls, but from what lay beneath them. In the 19th century, everything changed. The Industrial Revolution brought new materials, iron, then steel, and later, reinforced concrete. These materials demanded new thinking about foundations. Buildings grew taller, bridges stretched farther. Engineers like Gustave Eiffel and Joseph Paxton began testing prefabricated iron structures and glass frameworks. And beneath it all, foundations evolved. The advent of pile driving, where long columns of wood, steel, or concrete were driven deep into the earth, allowed construction on previously unusable land. The technique allowed skyscrapers to rise in Chicago and New York, anchored deep into bedrock. Engineers studied loads, vibrations, wind resistance. The science of soil mechanics emerged. Foundations were now designed with detailed calculations, stress tests, and structural models. A new era of confidence dawned. Humanity could now build faster, higher, and in more places than ever before. In the 20th century, cities reached toward the clouds. From the Empire State Building to the Burj Khalifa, modern skyscrapers rest on foundations that penetrate dozens of meters into the earth. Engineers create concrete rafts, caissons, and pilings capable of supporting unimaginable weight. In earthquake-prone zones, base isolation and flexible footings allow tall buildings to sway rather than snap. In dense urban areas, foundations must work around subways, sewers, and other underground systems. This century also brought innovation to housing. Suburbs expanded, prefabricated homes appeared, concrete slabs, poured foundations, and modern insulation became standard. Building codes were written and enforced, guiding safety and structure. The world began to consider not just strength, but sustainability. Green buildings, solar-powered homes, and eco-foundations now take their place alongside steel and concrete. Today, as we look ahead, we stand on millennia of wisdom. Foundations now blend science, technology, and environmental care. We build on sand, on water, on hillsides, and even below the sea. With 3D printing, drones, and AI design, buildings are becoming smarter, and so are their beginnings. Floating foundations may someday support ocean cities. On Mars or the Moon, we may use regolith, the dust and rock of alien worlds, to make bases for the first off-Earth shelters. But at the heart of it all remains a simple truth. A building is only as strong as what it stands upon. As we drift back through time, past domes and palaces, past huts and temples, we return to the quiet wonder of that first shelter, a circle of stones around a fire, beneath a sky of stars. Humanity's journey in building has always been about more than wood and stone. It is about protection, expression, connection, and above all, learning. Through trial and error, collapse and triumph, we have built not just homes, but civilizations, and it all begins with a foundation.